Alrighty. Happy Wednesday, hump day, right? Middle of the week. So let's answer this question. So if we look here, look at these two figures. What do you notice? What do you wonder? So let's see what people are saying. I noticed they reflect each other in the picture. It's a reflection. I noticed the shape is reflected and all the x-axis coordinates went from a positive number to a negative. I noticed that the picture looks as though the image is just reflected and it's turned around but on the same lines. I noticed the picture looks like a reflection of the pre-image. Ooh, good job. Use some of that vocabulary. I noticed that the object is mirrored. Ooh, I like that word. It's mirrored, reflected, mirrored. Left side is negative and right side is positive. I wonder what we do knowing it's a reflection. Good, our first wonder. I noticed it looks like a mirror effect. I noticed that ABC has a horizontal reflection and wonder what is the equation to get the reflection. Okay, another wonder. Good. The figures are in the same spot on opposite sides of the y-axis. I think it's a picture. I think that the picture is an example of reflection. Nice. Why are they opposites on the x? That's a wonder. Nice. The triangle is reflected on the y-axis. What I notice about the picture is that the image triangle A prime, B prime, C prime is a reflection of the pre-image triangle A, B, C. What I wonder about the picture is which axis is the triangle A prime, B prime, C prime reflected on. Nice. I wonder how the coordinates would be, coordinate notation. Oh, would we use coordinate notation for this? It's reflecting or rotated 180 degrees. So this person's saying, it's either reflected or I rotated it around. Which one is it? So that's what they're wondering. If it's reflected or rotated. What I notice is that they are the same, but the other side is negatives. I don't wonder anything. Okay. All good questions. All good answers. Good job. Good job. So let's look at this. You guys are right. It is a reflection. It is a reflection. We did reflect. We went. But how? That's the wonder, right? How did we reflect it? We can see it's flipped. It's kind of like, let's see. Do I have I don't have a triangle. I should have some shapes here, shouldn't I? I thought I should just have shapes here. So let's make a triangle. How about that? So I'm going to make a triangle with this paper. Sorry, it's not the best triangle, but and so here's my triangle, okay? And if I'm going to reflect it like a mirror, let's make this pen the mirror. If I'm going to reflect it, it's going to flip over to the other side. See that? It's going to do a flip, right? It's not, if it slides, it stays there. But since I flipped it, you notice it changes its orientation. Remember we talked about that before, the orientation, the way it's pointing, kind of. Right, so this is pointing, the pointy side is on the right. Now, when I reflect it, the pointy side is on the left. It's the same exact figure, right? The pre-image and the image are exactly the same, but the orientation's changed because I flipped it over, right? I flipped it over. Okay, so how do I do that? A lot of you were wondering how. Like, is there an equation? Do I write it in coordinate notation? How do I do this? So that was the wonder, and I like that. So we're going to have a lot of warm-ups like that where I give you something and I just say, what do you notice? What do you wonder? And there are no wrong answers in that kind of question, right? So those are, I'm going to try to give you safer questions because remember how we're trying to dance with our fear, right? We're trying to dance with our fear. And so one way to do that is, if you're afraid to answer warm-ups or you're afraid to answer questions, how about I give you questions that are safer, questions that don't have wrong answers? Right? That would be a lot better for some of you to say, "Oh, okay, I can do those. I can do safe questions. I can dance with that fear." Right? The fear is a little smaller. I can, since the fear since that little lizard gets a little smaller, I can lead the dance. I can do that. Right? You can still be afraid, but maybe that would help a little bit. So we'll do that. We'll do a little more warm-ups that are safer. Of course, we'll still have warm-ups where you have to answer questions directly. And there is a right answer. And those of you are like, okay, but maybe by doing these where there's no wrong answer, you'll feel safe. So how do we do this? Okay. Before we do that, if you did not take the Renaissance STAR test, please do that today sometime. It's still open, so go there today sometime if you didn't take the Renaissance STAR math test, okay? Remember, you go to Schoology, you go to our course, you go right here on the left side, Renaissance Learning, and then it'll take you to the test. Click on the math one. I had a few people ask me yesterday, the math one? Are we doing the math one, mister? Yes, we are in a math class, so yes, we are doing the math one. So let me show you. So if you go to your courses today, period 11, you'll see that there is a week 4 materials folder. So you click on that, and you'll see there the video from Monday. We didn't have a video yesterday because we were doing the test. So the video from Monday is there. Remember, you could always go back, and then week 3 videos are in the week 3 folder. You can always go back and look at the videos of what we've done before. And if you notice here, we have reflections notes and reflections homework. And again, if you open this in Google Chrome, you can work on it in Kami. Now, you can only do that on your Chromebook or a laptop. It doesn't work on an iPad. If you notice here, if I click reflections notes, because this is my iPad right here, there's the PDF, and it does say view, but there is no open with Kami option. That only works on your Chromebook or your laptop. Okay? So those of you saying, Mr. Some of you sent me, it's like you forgot for a semester, some of you. How do I turn in my homework? I can't do Kami because I'm using an iPad. Do it on a piece of paper and then turn it in that way. Okay? Does that make sense? Okay, so then you open the reflections notes. I'm going to give you a minute. And let me put an actual timer. I'll give you a minute to go ahead and get to these notes, open them up, print them out, open it up on another tab. I know some of you are like, Mister, I don't do that because I just watch you and I take your notes, and then later on I can copy the other stuff or I print it out later. So I'll give you a minute to do whatever you do, to get your handy-dandy notebooks or whatever you need to get, because we're going to start new notes right now, okay? So I will give you a minute to do that. Oh, I have a poll for you guys. The other 2 periods did it, and for some reason I didn't do it for you guys. All right, we'll have to do it at the end of class. This was causing this to freeze up a little bit. Yeah, look what happened. Okay. What happened? You still have 2 seconds. What's going on? All right, so I don't know why you still have 2 seconds. That didn't make sense. Okay, so time's up. So however you got your notes, I think I want to do a survey to see how you guys take notes, because I wonder, see, that's my wonder. How do you guys take notes? I want to see, because maybe there's something I can do that would make it easier. I know that was a long 2 seconds, right? I don't know what happened. See, I try to open up a poll, and I tell you, when I record with this program I use this semester, it freezes up my system. And I have a whole bunch of RAM in here, too. I don't know why it freezes up my system. All right, so So is there, before I do go on, is there anything you can send me in the chat? Is there anything I can do to make you taking notes easier? I did it, so now you can open it with Cami, so that helps a few of you. I know some of you will be like, yeah, can you print it out for us and send it to us? Yeah, that would be great, right? So you can have a packet. I wish I could do that, but I have too many. I have 100 students, so that's 100 stamps. I don't even know how much stamps are right now, and so that's like, okay. But so if there's anything I can do, please let me know. All right, reflections. What are reflections? Reflections, well, you know, translations is this slide, right? Well, reflections is a flip. Oops, that's a little too thick. That's a flip over a line called the line of reflection, or the reflection line. What? Really? Yeah, that's pretty simple, right? We call it the line of reflection, the line we're going to reflect over. So when you look here, can you tell what the line of reflection is on this picture right here? Can you tell what that mirror, what is it? What's the line of reflection here, guys? The y-axis, right? This is my line of reflection. And how do you know? Well, let's look at this. If you wonder how you know, let's look at this. You see C and C prime? You see how C is 1 unit away from the line? C prime is 1 unit away. Right? Every point should be the same distance away from the line. If you look at B, B is 1, 2, 3 units away, and B prime is 1, 2, 3 units away. And A is 1, 2, 3, 4 units away. A prime is 1, 2, 3, 4 units away. So if you look at it that way, each point, and this is the next line right here, each point and its image are the same distance from the line of reflection. Somebody saw it. Someone saw Bernie in the corner. I was waiting for someone to find it. All right, so reflection is also an example of a rigid motion, meaning it keeps the same size and same shape. Okay, so I'll give you a second to copy this. If it's a little blurry, let me know. I'll zoom in. Again, yeah, sometimes it's my internet, sometimes it's your internet, sometimes it's both of our internets. And then Zoom doesn't make it easier because Zoom, it always makes it lower quality for some reason. But again, these recordings are all put up on YouTube. And so if you want to see our some of the notes again later on, it's in 4K, so it's a lot clearer, so much clearer when you click on the videos. And then, and if you can also subscribe to that channel just to help me out. I'm trying to get to 1,000. I'm at 334 right now. So if you do click on a video and you're there, you could just hit that subscribe button. Just smash that subscribe button. And that would help me out. So I'm trying to get to 1,000. It's taking me a while. And maybe I'll do some other videos. When you go to when you click on the videos in Schoology, it takes you to my my YouTube channel. What does it say in parentheses? Same size, same shape. I know my chicken scratch sometimes. Yeah, and call me on that, guys. If my writing is bad, oops, tell me. Hey, mister, can you rewrite that? Same size, same shape. That's what rigid motion means, right? Same size, same shape. Okay? All right, so a reflection is a flip. And here are the most common lines of reflection. So these are the ones we're going to look at. And these are the most common lines of reflection, okay? We're going to look at the x-axis as a line of reflection or the y-axis as a line of reflection. Okay? We're going to look at vertical and horizontal lines. If you remember from algebra, vertical and horizontal lines have equations. So when x equals a number equation, x equals equation is a vertical. That's a vertical line. Right? So if you see like x equals 7, it's going to be a vertical line and it hits x at 7. Or excuse me, sorry about that. Or a horizontal line, which has an equation, y equals some number. So a horizontal line is a y equals equation. Okay, so you'll see that. So either the x-axis or the y-axis are going to be your line of reflection, or an x equals number or y equals number, or, and I'll show you this, if you don't understand what this is, it's okay, or the diagonal equation, y equals x or y equals negative x. So those are the most common lines of reflections we're going to look at. We're going to first look at the x-axis and the y-axis as being your lines of reflection. Then we'll look at some vertical and horizontal lines. I'll give you the equations of those lines. And then diagonal lines, your basic diagonal lines. Now, you can have all kinds of complicated other ones like y equals 7x minus 2 or y equals 3x plus 7. You can have those, but we're not going to do those yet. We're just going to look at x and y axis, vertical and horizontal lines, and those two common diagonal lines. So that's what we're going to do. So we should do that today and tomorrow. And then that's a number. That's just a number sign, right? That just means any number. X equals a number. Or y equals a number. That's a hashtag, mister. No. Well, that means number. Okay. So I'm just telling you, a horizontal line is a y equals number, and a vertical line is x equals a number. Okay. When we get to those, I'll explain a little more. But yeah, just it could be any number after x equals 7, x equals negative 2, x equals 5. It just means that x equals a number. All right, any questions? This is our intro. Reflection is a flip, right? It's a flip. I get a shape. Oh, where's my shape? I don't have a shape. Where'd my shape go? All right, I lost my shape. But you get the shape. All right, here we go. You get your shape and you have a, oh, that's a magnet. You have a line of symmetry, and then you flip it over. Flip it over. Okay, that wasn't the best example. I need to get some shapes. I will get some shapes. I will do so. Okay. Each point is the same distance from that mirror or from that line of reflection, right? So that's how you flip it over. That's the basic way you flip it over. You look at the point, and then you say, okay, how far is it from the line of reflection? 4. So then I go in the opposite direction this way. And so those of you that were wondering, on the warm-up. Why was the X number the opposite? Well, if the Y-axis is the middle, that means the Y-axis is 0. And if this is -1, -2, -3, -4, if this has an X coordinate of -4, then if I go 4 in the opposite direction, this is going to have an X coordinate of +4 because it's the same distance. If I go 1 backwards here, I go 1 forward here. So let's do a problem. So we're going to begin with the easy ones. Oh, you want more time to copy? Sure. Sorry. Let me shrink myself. There you go. And don't forget Friday. No, that's what okay. The question we're going to do at the end of the period while you're copying is, what day do you want camera day? Everyone chose Friday. Third period and fourth period chose Friday. So I want to know what day you guys. So we'll do a little poll at the end of the period. Okay. I'll give you 1 more minute to copy because we do need to move on. And again, if you want to come back and you miss something, you can always click on the video. You need to give it a little time because I do, right after class ends, I do upload it to YouTube. But you know how YouTube is. If you go right away, you're going to get the ugly version because it hasn't rendered yet. You'll get the 360p version. It'll be really blurry, and you'll be like, "Mister's a liar. It's blurry." You got to give it maybe an hour or so. So by the end of the day, for sure, you can go click on the video, and the HD version will be rendered because it takes a little while for YouTube to process the HD version. So yeah, give it a minute. So I'll give you another 20 seconds to copy this. We need to move on. You just want us to go to yours. No. I'm just saying we can't just spend the entire period on these top 2 slides. We got to actually do some problems, right? Because a lot of you were wondering, how do we do this? And I'm going to give you a little clue. We do not use coordinate notation. We use that line of reflection, right? That line of reflection tells us where the other points, the new points, should go. All right, 5, 4, 3, 2, 1, 0.5, 0.25, 0. All right. So let's look at this. So now we're going to first look at the easy ones. We're going to reflect on the x-axis and the y-axis. Okay, so let's look at number 1. So, let's look at the instructions. Always look at the instructions. Graph and label each figure and its image under a reflection in the given line. Give the coordinates of the image. Okay, so just graph the pre-image and the image. So here we go. So we have a triangle ABC with vertices A. So let's plot this. A, -4, 2. 1, 2, 3, 4, 1, 2. So there's A. B, 4, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. There's B. And C is 5, 1. 1, 2, 3, 4, 5, 1. C. And so if I connect those dots, there is, that was bad. There is, come on. What, this is not working? There we go. So there's my pre-image, ABC. So I need to reflect it over the x-axis. So what I like to do is I like to draw or highlight my mirror, my line of reflection. So there is my line of reflection. So now I need to get this image and flip it over to the other side. So how do I do that? Well, let's look at this. What I like to do, some people like to go in alphabetical order, right? We're just going to move the 3 points. Again, we look at the 3 vertices. And what I like to do is I like to start with the one that's closest. So if you look here, C is the closest to the mirror, right? C is closest to the line of reflection. And how far is C from the line of reflection? It's 1 away, isn't it? So what I'm going to do is I'm going to draw C prime over here because that is also 1 away from the line. See how this is 1 away? And then C prime would also be 1 away, but on the other side. Now let's look at A. A is the next closest, right? Oops, I don't want that. A is how many units from the center? From the line. 1, 2. It's 2 units, right? So that means A prime would also be 2 units, but on the other side. And so I'm going to go 1, 2, and so A prime would be right there. And then B is the farthest one, so I got to do a little counting. How far is it? It's 1, 2, 3, 4, 5, 6. It's 7 away. It's 7 away from the line, so I'm going to do that in the other direction. 1, 2, 3, 4, 5, 6, 7. And there's my new B. And then I connect these dots. And you will see a reflected image. And there it is. Guys, see that? All I did was I counted how far each point was, and I did the same thing on the opposite side. So you can see that in orange. I just counted how far each of the original point was away from the mirror. I call it the mirror. It's the line of reflection. How far it was away from the line of reflection. And then I just, on the other side of the line of reflection, I count the same amount of units and plot my new point. Does that make sense? If it doesn't make sense, if you are confused, please send me a message, a direct message on Zoom and say like, hey, mister, what did you mean by that? Okay, I'll give you time to copy. Any questions? I don't see any questions. Does that mean you all understand it? Right. As long as you have the original image, the original figure, the pre-image, and you know the line of reflection, I like to put it as a highlighter so it can be really clear to me that that's the line I'm flipping over. And then all you do is look at the points, look at the end points, the vertices, A, B, and C, and then count how far is it away from that line of reflection. And however many units it is away from that line, you're going to do the same thing on the opposite side to get the new points. So C was 1 unit away, so it's going to be 1 unit away on the other side. A was 2 units away, so it's going to be 2 units away on the other side. And B, which was the farthest one, was 7 units away on one side, so it's going to be 7 units away in the other direction. Okay? Any questions? All right, 10 more seconds, and we're going to do the next problem. Five, 4, 3, 2, 1. All right, so now let's look at number 2. Let's look at number 2. Rectangle. So now we're moving a rectangle. P, Q, R, S with those vertices. And now the y-axis is our axis of symmetry. Our line of reflection. So I'm gonna actually do that first. That's my line of reflection. Okay, I'm going to highlight that, and then I'm going to plot the points for P, Q, R, S. P is 1, 2, 1, 2. So there's P. Q is 2, 5, 1, 2, 1, 2, 3, 4, 5. There's Q. R is 8, 3. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. That's R. And S is 7, 0. 1, 2, 3, 4, 5, 6, 7. And then I don't go up or down because it's that Y is 0. So there's S. And so there is my rectangle. Okay, so now I'm going to, I have everything I need. I have my original image, my pre-image, my original figure, and I have the line I'm going to go across. So it's going to go this way. So all I do is I count. So I'm going to do the closest ones first. So P, you see how it's 1 unit away? So I'm going to go 1 unit this way. And so my new P is right here, P prime. Q, if you look here, Q is 2 units away, so I'm going to go 2 units in this direction, and there's my new Q, Q prime. Now, let's see, what's next? S and R are pretty far, but so I can choose either one. So if I look at S, how far is it from that line? It's 7 units, isn't it? So I'm going to go 7 units in the opposite direction. 1, 2, 3, 4, 5, 6, 7. And there's my new S, S prime. And then I'm going to do the same thing with R. How far is R? 1, 2, 3, 4, 5, 6, 7. It's 8 away. So I'm going to go 8 in the other direction. 1, 2, 3, 4, 5, 6, 7, 8. And there's my new R, R prime. Connect the dots. And I am done. There you go. There's my reflected figure. So again, all you need is the original figure, the coordinates of the original figure, and draw it. And then I need that line of that line of reflection. It is a line of symmetry, but a line of reflection, right? So I can reflect to the other side. And then I count how far each point is from that line of reflection, and then I do the same thing, but on the opposite side of the line, right? Because I'm mirroring it. Is this clear, guys? If it's not clear, if I'm being confusing, if you're still not understanding, please let me know. Please let me know, because it's dangerous. It's very dangerous to not ask if you have a question. Okay, so that's it for today. So we looked at X, how to reflect over X-axis, how to reflect over Y-axis. The steps are the same for any axis, right? Any line of reflection. But we looked at X-axis and Y-axis. Tomorrow we're going to look at, okay, how do we reflect over a horizontal or a vertical line that has an equation to it, like X equals 5 or Y equals 7. How does that work? And what are these diagonal lines, mister? What did you mean by Y equals X and Y equals negative X? What the heck is that? We'll talk about that too, and how to reflect over that, how to reflect over a diagonal. Reflecting over a horizontal and a vertical, easy. Reflecting over a diagonal, still easy, but a little bit more things you need to do. And we'll talk about that tomorrow. Okay? So if you don't have any questions, that's pretty much it for the day. Okay, so take care, guys, and I'll see you all tomorrow.